So benzene ring. So okay, this is the structure of sulfonamide. So we are studying about the chemical structure based on the chemical structure. Isn't it? Sulfonamide. So this is a benzene ring. Then sulfur is substituted to two oxygen atoms. Sulfur is substituted to the two oxygen atoms. So this we call it as a ketone attachments. And sulfur is bonded on other side with nitrogen and alkyl substituted group. Alkyl substituted group. On the other side, the benzene is attached towards the amine. Okay, so this is the structure of the sulfonamide. Similarly, various derivatives, various drugs are there depending upon the type of the functional groups getting attached. So instead of ketone, carboxylic acid can be there. Even nitro derivatives can be attached, isn't it? Instead of sulfur, it can have chlorine. Instead of sulfur, it can have sodium. So any other metal can be substituted, isn't it? So depending on the structure, the drugs will be exhibiting its own action. So example is sulfonamide, that is the sulfur. The last one we are calling it as a molecular targets. The molecular one is the molecular targets. Molecular targets are the drugs which interact with the macromolecules. What are the macromolecules? The macromolecules are nothing but carbohydrate, proteins, nucleic acids like DNA, RNA, nucleic acids are the macromolecules. So the drugs will be interacting with the macromolecules. That is called as the macromolecular target. Under the macromolecular target, we have enzymes and receptors. Understood? So these are the classification. So first what we have studied, what are drugs. Now we are studying about what? The classification of drugs. So drugs are classified under four categories. Pharmacological, based on the pharmacological effect, based on the drug action, based on chemical structure, based on the molecular structure. Based on the pharmacological effect, we can write two points. That is the drug which interacts with the cells of the living organism. Second one, example, the whole range of the drugs like analgesics, antiseptics and antibiotics can be used as the whole range of drugs for the treatment of certain kind of the infection taking place in the cells. Then the next one is what? Drug action. So for the drug action, the drug interacting with that of the biochemical reactions. So example is histamine and antihistamine, inflammation, keep that in your mind. Then chemical structure, based on the chemical structure we can classify the drug. The drug exhibits its action on the targets depending upon its chemical structure. Example is sulfur drug, sulfonamide. The molecular targets, the drug interacting with the macromolecules. What are the macromolecules? Enzymes, receptors. The macromolecules are carbohydrates, proteins and the nucleic acids. So example for the macromolecular targets are the enzymes and receptors naturally which is present inside our body. Understood? The classification of drugs. Now we will go for drug enzyme interaction and receptor drug interactions. That is very, very important. You will get questions from that. So now the enzymes. See, these enzymes are made up of proteins and they are all biocatalysts present inside our body. Okay. Now these enzymes will take the enzyme interacting with molecules or a molecular substance. Okay. So first, how the enzymes interact with that of the molecular substance or molecular targets. That we will see. How enzyme interact with the molecular targets. First one, this enzyme when you take will be having, this is an enzyme. The enzyme will be having a specific site. That specific site is called as an active site. It is called as what? The active site. Okay. Then the enzyme, as and when it sees the molecular targets. That molecular targets we call it as the substrate. As and when it sees the substrate, the active site will goes and binds with that of the substrate molecule. It goes and binds with that of the substrate molecules. It goes and binds with that of the substrate molecules. What is the first point? The enzymes. No. Active site. This is the active site. This is an enzyme, isn't it? The active site of an enzyme holds, active site of an enzyme holds the substrates. Okay, the substrate molecules, it holds. If the substrates very firmly attached towards the enzyme. Okay, second point, the substrates attached to the enzyme by means of first point. So, எப்படி இந்த substrate போயிட்டு இந்த enzyme ஓட attach ஆகுது, firm attach ஆகுது, அதுக்கான reasons. First point is dipole-dipole interaction. Dipole interaction by means of dipole-dipole interaction. Second one is van der Waals interaction. Then third point is van der Waals interaction. Third one is by means of ionic bonding. Then fourth one is by means of hydrogen bonding. The substrates are firmly attached towards the enzymes. Now, third one, as and when the substrates are attached towards an enzyme, the enzymes starts to produce functional groups. It starts to produce examiner last in 1 month, starts to produce the functional groups. It starts to produce the functional groups. Now this functional groups will inactivate the substrate molecule. Finally what happens? The functional groups, I'm writing here. Functional groups. What point? Third point I had written here. No? Now coming to the fourth point. What is the fourth point? The functional group where the functional group is present. Functional group of an enzyme inactivates the substrates. Inactivates the substrate. Understood? This is what? This is naturally occurring phenomenon. This is what? Naturally occurring phenomenon in our body. So, so we are studying what is heading? Enzyme targeting the molecular substance. So, enzyme molecular target. How enzyme is interacting with the molecular targets. Okay, first enzyme. Enzyme will be having got active site. Then this active site will hold the substrate. This is a target molecule. Substrate molecules are the target molecules. It interacts. So it interacts by means of what? Dipole-dipole interaction, van der Waals interaction, or ionic bonding, hydrogen bonding. With the help of any one among this, the substrate molecules will be very firmly attached towards the enzymes. Now this enzyme will start to, as and when the substrates getting attached, the enzymes will start to produce the functional group. This functional group of an enzyme enzyme will inactivate the substrate molecules. This is the concept, naturally occurring phenomenon in our body. Now, what I am going to do, I am going to take a drug. This drug is going to target the enzyme. Upper drug targeting the enzyme or interacting with that of the enzyme. So I am taking a medicine in order to inactivate the action of an enzyme. So what are the ways in which definite question நிறைய டைம் ரிப்பீட்டடா நீட் எக்ஸாம்ஸ் எல்லாம் கேட்கக்கூடிய क्वेश्चंस கேட்கக்கூடிய டாபிக் இஸ் drug enzyme interaction. Okay, board exams la kuda கேட்பாங்க 3 mark question. How the drugs interact with that of an enzyme, that we will see now. So drug interacts with an enzyme by means of 3 concepts. One, we are calling it as by means of enzyme inhibitors. By means of enzyme inhibitors. First thing. Now coming to the second one, by means of enzyme inhibitors. Second one is by means of competitive inhibitors. The third one is allosteric site. Allosteric site. Okay. Now we will see one by one. So enzyme inhibitors. Enzyme inhibitors, we know the enzyme. This is our enzyme. This is the binding site of an enzyme. Isn't it? Now when we take the drug, so we know this active site is very important in order to hold the substrate molecules. Now as and when I take the drug, it just goes and inhibits the active site of an enzyme to hold the substrate molecule. Can you understand? It will inhibit an enzyme. It makes the enzymes inactivate or deactivate the enzyme in order to hold the substrate molecule. So then it cannot hold the substrate molecules. It deactivates the enzyme, particularly the active site of an enzyme. So that is called as enzyme inhibitors. What are enzyme? The drugs acting as what? Enzyme inhibitors. Enzyme inhibitors means what? It goes and deactivates the active site of an enzyme, so then it cannot hold the substrate molecule. First one. Then what is meant by competitive inhibitors? Competitive inhibitors means drugs will be there. So this is enzyme and this is substrate and this will be the drug. So now what happens? Before the substrate is getting attached towards the active site, the drugs will go and attach towards the active site of an enzyme. So there is a competition between the substrate and a drug, which will be occupying the active site of an enzyme first. So which one will be attaching towards the active site of an enzyme first? The drugs. So that is why it is called as competitive inhibitors. Drugs are acting as a competitive inhibitors. It inhibits the substrate and thereby it goes and attaches towards the active site of an enzyme. So that is why we are calling it as competitive inhibitors. Okay. Then the next one is called as allosteric site, which is very, very important. Allosteric site. We know already the structure of enzyme. How enzyme will be? Enzyme is like this, isn't it? The enzyme is like this. Now, this is the drug. This drug, instead of occupying the active site of an enzyme, it just goes and occupies on any side of the enzyme. Okay, other than the active site, this drug goes and occupies the any other side other than the active site of an enzyme. It goes and occupies the side other than the active site of an enzyme. Then what happens? Since the drug is getting attached towards the other side of an enzyme, this active site will become flattened. It will not resume its original shape. No, because here the drug has got attached. So as a result, this protrusion will not be there. Instead, it becomes flattened. So this active site will become flattened. So when it becomes flattened, though if the substrate goes there also, the substrates cannot be occupied because it has got flattened. It is not having its original shape. The active site do not have the original shape. Why? Because the substrate, the drug has occupied the other space in an enzyme. So that is why the active site of an enzyme has become flattened. Can you understand? In these 3 ways, the drugs retards the activity of an enzyme. It retards or inhibits the activity of an enzyme. Can you understand? So this is drug target interaction. Drug target interaction by means of by acting as the drugs acting as an enzyme inhibitors. Drugs can act as an competitive inhibitors. Drugs can also act as an allosteric site. Can also act as what? Allosteric site. So this is drug enzyme interaction. So again we will see. So what we have studied now, enzymes. Enzymes are the proteins and they are acting as what? They are acting as the biocatalyst. So now we take enzymes interacting with other molecular targets. So first we are taking an enzyme. Enzyme will be having an active site that going to interact with that of the target molecule, that is a substrate. Now this substrate will goes and attaches towards the active site of an enzyme. So active site of an enzyme. Now the substrate should be hold very firmly towards the active site by means of either dipole-dipole interaction, van der Waals interaction, ionic bonding, or by means of hydrogen bonding. Ionic bonding and hydrogen bonding will be very strong bond. Van der Waals bonding will be a little weak or a brittle bond. Now third one is enzyme starts to produce once for all the substrate is getting attached towards the active site of an enzyme, then immediately the enzyme starts to secrete the function group, which makes the enzymes activate on the substrates. It reacts with that of the substrate molecules. Okay. Now next one is, this is naturally occurring in our body, whereas this one is artificial. So now I am going to make this enzyme inactivating by using a drug. So for that what I am using a specific drug in order to interact with that of the enzyme. Now the enzyme, when I am using the drug, this drug can act as either an enzyme inhibitors, competitive inhibitors, or otherwise an allosteric site. So first one is enzyme inhibitors. What are the enzyme inhibitors? The drug which acts as the substance which prevents the active site of an enzyme to hold the substrate molecules, that is called as enzyme inhibitors. Directly attacking the active site, then enzyme inhibitors. Competitive inhibitors means what? The substrate will be there, drug will be there, the drug goes readily occupies the active site of an enzyme, then the substrate molecules. Once the drug occupies, the substrate will not find the space in the active site. So that is called as what? Competitive inhibitors. So that inhibits the substrate molecules. Third one is allosteric site. The drug goes and attaches towards the enzyme on any part of the enzyme other than the active site. So then what happens? Since the drug occupied a specific part of an enzyme, this active site will become flattened, cannot have its own shape. Since it becomes flattened, though the substrate molecules goes there, it cannot get occupied because the original structure of the active site has been changed to a flattened nature. Understood? This is called as enzyme interaction. Now, next one is receptors. Now we go to the next topic is receptors. That is also very important. The receptors. Now we pass it on to the next topic. The next topic is the receptors. So now see the receptors. The receptors are made up of proteins. Specifically, it is made up of glycoprotein. It is made up of what? Glycoprotein. And these receptors are present on the surface of cell membrane. And this main function of the receptor is cell signaling, or otherwise we can call it as a communication, cell communication, or otherwise we can call it as cell signaling process, cell signaling or otherwise cell communication. So what are receptors? Receptors are nothing but receptors made up of proteins. What type of protein? Glycoprotein. Where do these receptors are present? These receptors are present on the surface of the cell membrane, plasma membrane, surface of cell membrane. And these receptors, so the main function of them, it helps in cell signaling and in the communication. In the communication, cell communication process, the receptors plays a very significant role. Can you understand? That is a case of enzymes. What we studied, enzymes are a protein, not It is made up of a protein, general protein. Then where the receptor enzymes are present inside the living And what is the main function of the enzymes? The enzymes are acting as a biocatalyst. Here, what is the function of receptors? It helps in cell signaling and in the communication process. Now, we go for receptor targeting or interacting the target molecule. We see natural process taking place inside the living organism. Now what happens? You know the first we must know the structure of the receptor. I told you the receptor are present on the surface of the cell membrane. So the cell membrane will be having the receptor like this. So this region is called as binding site of receptor. Whereas in case of enzyme we studied active site. Whereas in case of receptor, binding site. So this region is called as the binding site. This binding site will bind the chemical messenger. Will be binding what? It will be binding the chemical messenger. Will be binding the chemical messenger. So chemical messenger bind towards the binding site of an receptor. Okay, this chemical messenger will bring the messages. That messages will be between nerve cells to nerve cells, neurons to neurons. Whether you know nerve cells to nerve cells, or otherwise nerve cells to muscles. Nerve cells to the muscles. The messages can be transmitted. Can you understand? So it receives the messages like this, and accordingly it will be giving the response. The cell will be giving the response to the stimulus. This is how the natural process is taking place. Now what I am going to do? I am going to take a drug. This drug is going to interact with that of the receptor. Okay. So drug targeting the receptor. When the drug targets the receptor, what are the things will happen? We'll see. One we are calling it as antagonist effect. The other one is called as agonist effect. Antagonist effect. The other one we are calling it as agonist effect. What is this antagonist effect? Is the binding site of the receptor will become fragile. So the structure of the binding site will get the structure of the binding site of the receptor will become fractured enough so that it cannot receive the chemical messenger. What is agonist? It minimize the chemical natural messenger from the nerve cells or from the brains reaching the binding site of an enzyme. So first antagonist affects what? It alters the binding site. It alters the binding site of receptor. Binding site of the receptor. What's happening here in case of agonist? Agonist will minimize the natural messenger. Will minimize the natural messenger. This is about the receptor. So receptors, what are the points we will be studying about the receptors? Receptors are nothing but it's a protein. What protein? Glycoprotein. Then next one, the receptors are present on the surface of the cell membrane. What is the main function? It helps in cell signaling and in the communication process. Now receptor interacting with that of a target molecule. The receptor will be having what is this? This is a receptor, isn't it? This is receptor. The receptor will be having the binding site. The binding site will interact with that of the chemical messenger. What is a chemical messenger? It is a chemical substance that brings the messages from nerve cells to nerve cells or otherwise nerve cells to the muscles. So when the chemical messenger is reached to the binding site, then automatically the response will be getting produced. It will be in a form of cycle. Now when I am taking a drug in order to inhibit the action of the receptor, then two activities will be exhibited by the drug. The first one is antagonistic behavior and the other one is agonist. Antagonist means what? It alters the binding site of the receptor. What is agonist? Agonist will minimize the messages, natural messenger. What is the natural messenger? The natural messenger is the chemical messenger inside our body. So it minimizes the natural messenger of the body. So this is about the receptors. So we studied about drugs, classification of drugs. Then the third one is receptors. The fourth one is enzymes. Receptors and the enzymes. Okay. Now we go for this. Next topic is medicine. Under the medicine, the first one is antacid. So we have to study about antacid. Again, first point. What are antacids? The antacids are the chemical substance. Chemical substance. This chemical substance will neutralize. What it neutralize? Neutralizes the acidity or otherwise acidic content in the stomach. In the stomach by a process of neutralization. By a process of neutralization. So what are antacids? The antacids are the chemical substance. That chemical substance will neutralize the acidity or otherwise acidic content in the stomach. So when the acidic content is getting neutralized, it results in the removal of stomach irritation, even ulceration. Clear? It prevents or it helps in the removal of stomach irritation and ulceration. Removal of, you can write down otherwise prevention of. Okay. Now, we will go for the examples. The chemicals which can be used as the antacids are initially sodium bicarbonate NaHCO3 has been used as an antacid, and then mixtures of aluminium and magnesium have also been used as an antacid. So when you take this sodium bicarbonate, the sodium bicarbonate is made up of bicarbonate ions. What is the bicarbonate ion? HCO3 minus ion. This bicarbonate ion naturally it is an alkaline substance. What is this alkaline substance? Alkaline substance or a base. It acts as a base. It's an alkaline substance which acts as a base. Which acts as what? Bicarbonate ion. It's an alkaline substance, acts as a base. When we take base inside our stomach, and automatically this base will stimulate the cells of the stomach to secrete acid. Again, the acid content will be very high. There will not be any neutralization to take place. So automatically the sodium bicarbonate cannot be taken as an antacid. The reason they asked in the exam, why sodium bicarbonate cannot be taken as an antacid. Sodium bicarbonate cannot be taken as an antacid because it has a bicarbonate ion. The bicarbonate ion is an alkaline substance. Naturally, it's an alkaline substance or a base. This base will go and stimulate the cells of the stomach to secrete an acid. Again, acid content will be increased. So there will not be any neutralization